Hello everyone from Chemistry and Society. My name is Elisa Wirch and I'll be sharing a bit about albedo and the albedo effect. Let's start with some definitions. Albedo, the fraction of the total light striking a surface that gets reflected from that surface. It also refers to the surface's whiteness, or how white an object is. Let's see, the value of albedo varies between 0 and 1. So what this is basically saying is albedo measures how much light is reflected from a surface. So an example is a surface with the value of 0. In principle, it should be black in color and is a perfect absorber. A perfect absorber would be a black hole, for it absorbs everything and it does not reflect any light back. The value of 1, the surface should be white and it would be a perfect reflector. No light would be absorbed from that surface. Everything would reflect right off of it. A good example of a high albedo reflector would be fresh snow. It's not 1, but it's close. All right. Here's some surfaces and different examples of their averages in albedo. Let's start with, of course, as I mentioned before, snow, which for Earth's average albedo, which is around 31%. It does vary though. Snow is a big contributor to Earth's total albedo because, as we know, about half of the year the northern hemisphere is covered in a lot of snow. So we know for about half the year the Earth's albedo goes up drastically. As you can see, asphalt, which is black for the most part, it only has 5% or 10% light being reflected off of it. So it has a pretty small albedo. Another example of albedo is in different water bodies. As you'll see, it's anywhere between 10 and 60%. That's because albedo on water varies. If it's deep water, it's a darker color, so there'll be less albedo. So as the water gets shallower, in reality it should be more reflective, so it should have more albedo. Also, where the sun is in the sky and where it's reflecting its light affects albedo. Another interesting fact, if water is choppy like in the oceans and there's a lot of white caps, those little white caps have a high albedo because of their coloring. Now here's an example of the albedo effect. When sunlight comes down and hits a surface that has albedo, depending on how much albedo, that's the percentage of light that'll be reflected back. And then depending on how much it absorbs, that's how much gets either into the object, or in the cloud's case, it goes through the cloud and to the surface of the Earth. I focused on the clouds because I wanted to take a look at clouds' effect in the Earth's overall albedo. Also, another important factor about the albedo effect is scientists believe it has a cooling effect. When it reflects the sunlight, it keeps that surface cooler. In the case of clouds, when you have big enough clouds and enough of them, they tend to have an overall cooling effect over the area. And we can see that when we have storms that move in, it cools our temperature. All right. Now, one thing about clouds is that depending on what type of cloud you have, gives you a different albedo value. For example, high altitude cirrus clouds, like these ones here, they tend to have very little to zero albedo. For the most part, they're transparent. Lower altitude cumulus clouds, which are dense, they do have albedo. And if enough of them, again, get together and form a storm, they have an overall cooling effect. However, as we all learnt, clouds, water vapor, is considered a greenhouse gas. So it does add to global warming. But scientists believe that if you get enough of the denser clouds that have a good amount of albedo, it counteracts that global warming effect, and it tends to cool the area. Also, something to be noted, the type of photons that we're talking about in albedo, when the sunlight comes down, we're talking about visual light. So that light that falls in the visual region of the electromagnetic spectrum. I have heard a few sources say they think that some infrared light is also reflected, but I'm not 100% sure about that. For most of my studying and stuff, I've just dealt with visual light. All right. So what scientists are trying to discover is, with our increase in climate in the overall Earth, meaning that evaporation has increased, so more water vapor in the air, what type of clouds, if any, will be formed, how much will be formed, where will they be formed, and how will this affect Earth's overall albedo. Depending on the type of cloud, as we discussed earlier, if they're cirrus high altitude clouds, thinner, they won't have an albedo effect. Instead, they'll contribute to the greenhouse effect, causing more global warming. However, if there's enough lower altitude dense cumulus clouds created and they accumulate, they might contribute immensely to Earth's albedo and cause a cooling effect. But scientists really don't know exactly what's going to happen. They're looking at improving how they measure Earth's albedo, clouds albedo more specifically, how they're trying to increase to watching clouds in where they form, when they form, how they form, what kind of conditions are required, because they're hoping with a better understanding of that, adding to their already overall understanding of how Earth's climate and weather works. They think that'll be a bigger picture in the overall effect that global warming is going to be having on our Earth. I hope that's given everyone a good idea of what albedo and the albedo effect has to do with us and the Earth at large. And thank you for listening.